Hey again, welcome back. So we're back to the two-pump dilemma on trying to pump a two-component urethane system. Component A, component B, both in separate containers, running through two different pumps. We have a common switch that's used to actuate both of those pumps when they're operating in remote mode. And we have a handheld that's going to allow us to fill a sample mold for the test and measurement purposes. So what we did last time around was we set everything up, we ran some trials, and we found that the back pressure of the lines and the back pressure created by the original nozzle was just too great to allow, and it limited the flow through here. So what we've done now is we've reset the system up, we've refilled it, the system is full up through here, and what we're going to do is we're going to run some tests with some modified nozzles. We did take a lot of time to try and analyze what the problem was, and without any question, we know that there's flow restrictions created by the intricacy of the design in this folding design style of mix head. And what we really need to be using for a high viscosity or higher viscosity fluid like this is a helical static mixer. And we just have not been able to get any helical design static mixers that work with this kind of a cartridge system. It's going to require some more invention on our side. We'll have to redesign the whole gun head. But we know that it took about 30 seconds to fill a 5 milliliter mold running at our 100 milliliters per minute. So what we're going to do now is we're going to try and reduce that. So what we'll do is go ahead and install it like so. We will go ahead and set the speed on this. We'll jump back and we'll go into setup. We'll slow this down. Let's just set it down at 100 RPM, and that'll give us about 75 milliliters a minute flow rate. Jump back into remote. That gives us, that enables both the A component and the B component. And now we're set to run, and we'll fill a mold. And we stop. We're still getting some overflow, and we're overfilling, and that's largely due to the back pressure generated in the system. We did shorten up the tube length considerably in order to avoid overfilling, but we're now able to fill these molds significantly faster. So we're now filling a mold in about 10 seconds. So we've increased the flow by just slightly modifying these tips by a factor of 3. Okay, to get one more data point, what we'll do is we'll let this system come to idle here. We'll just capture that fluid. We're not doing a suck back, which we had originally planned on doing, because there's just too much risk about sucking mixed material back in there and polymerizing everything in the head. What we're going to do instead now is we're going to simply take and change out this head, and we're going to put on a shorter head. So what we're doing is we've reduced the number of turns on this folding design, so we're only turning 20 times. That, in conjunction with shortening up these tubes, really cuts down on the back pressure, and we should be able to run at a much higher rate. So we'll put ourselves into remote mode, start remote operation, and we can run it with the switch. We'll go ahead and fill the pump, and now we'll start to fill. And it takes about 6 seconds. During the last video, this same process was taking closer to 30 seconds to fill one of these 5 milliliter tubes. So what we really need to be doing is concentrating on coming up with a change in the mix head design, so we're getting away from this 90-degree fold configuration, and we need to go to a helical mixer. We were in contact with several vendors for helical mixers, but we were not able to come up with anything that's a bayonet style that would mate to this gun. But as it is, we're able to do this much faster. If you watch the previous video for reference, we've obviously increased this by many times. We're still getting a little overflow. That's due to the back pressure of the system, the expansion of these tubes. So even when the pumps shut off, you have the tubes collapsing down to their natural state, and that will continue to cause a little bit of flow for a couple of seconds. But I think that what we've done now has made a vast improvement in how the system runs. We can cap this off, and until we come up with another mix type, we're much faster than we were, and I think we've accomplished the objective that we set out to. When we get a new mix head, we'll try it again, and we'll see what we can do to increase our flow rate. All right, thanks very much.